Now let's look at something a little more intricate, and that is contingency tables and conditional distributions. So a contingency table is a two-way table where it basically lets you look at two categorical variables together. It shows how individuals are distributed along each variable contingent on the value of the other variable. So that's why it's a contingency table. So, if a smoker thinks that smoking is very harmful, and if a non-smoker thinks that smoking is very harmful. You can also look at people who respond that something's very harmful, whether they're a smoker or non-smoker, compared to not at all harmful. So the question is, you kind of want to look and see if there's a relationship between perceived risk of smoking and smoking status. Now, when we're doing contingency tables, you'll probably see marginal distributions. I don't really see it in the other textbooks, so I don't think it's really going to be on your AP test, but it is in this textbook. So the margins of the table, both on the right and on the bottom, give totals and frequency distributions for each of the variables, and each one is called a marginal distribution for that respective variable. So, for example, this is a marginal distribution of perceived risk because it shows the frequencies for each of the perceived risk and the total. So I took the rightmost column and put it with each of the perceived risk categories. This is a marginal distribution for smoking status. So I took the bottom row and put it with each of the columns of smoking status. So a contingency table of perceived risk by smoking status, the best way to see it is imagine an individual distribution for each perceived risk. So like each one is its own pie chart. So very harmful. Very harmful is its own pie chart. So 25.1% of smokers think it's very harmful. I should say 25.1% of the people who think it's very harmful are smokers, and 74.9% of of those who think it are very harmful are non-smokers. Now, what I just did there illustrates an easy thing to do, so be very careful. This is the percent of people who thought it was very harmful. Then you go 25.1% of people who thought it was very harmful were smokers. 74.9% of people who thought it was very harmful are non-smokers. Be very careful with that. All right. Of those people who thought it was somewhat harmful, 59% were smokers and 41% were non-smokers. So you see how the smoking status is the second thing I say when I'm describing each of these perceived risk categories. I can go the other way as well. I can do smoking status by perceived risk. So basically, I'm going to describe their smoking status. So 60.2% of smokers thought it was very harmful. 29.9% of smokers thought it was somewhat harmful. 7.1% of smokers thought it was not too harmful, and 2.9% of smokers thought it was not at all harmful. So this percentage of this by that, so what they thought. Okay, same thing for non-smokers. 86.1% of non-smokers thought it was very harmful. 10% of non-smokers thought it was somewhat harmful. 3% of non-smokers thought it was not too harmful, and 1% of non-smokers thought it was not at all harmful. So imagine making an individual distribution for each smoking status showing perceived risk. So I can make a pie chart for smokers and a pie chart for non-smokers. So a conditional distribution of perceived risk within each smoking status, that's like making my separate pie charts here. So I have my smokers and I have my non-smokers. Now I can go ahead and make a pie chart of that, and you can see that the pie charts do look differently. So if I'm looking at smokers, you can see that less of them think that smoking is very harmful. That kind of makes sense because if they thought it was really harmful, maybe fewer of them would smoke. Whereas most non-smokers think it's very harmful, and that could be why they're non-smokers. There is a small, tiny piece who thinks it's not at all harmful. So anyways, make sure your categories do not overlap when making a pie chart this way. Since no one is both a smoker and a non-smoker at the same time, there's no overlap there. And presumably they were only able to respond to one category. So now I'm going to leave you to try a problem. This is page 28, the just checking in your book, and the answers are on page 44, so you can see how you're doing. And it gives you a contingency table on eye color and gender, and they want to know what percent of females are brown-eyed, what percent of brown-eyed students are female, and what percent of students are brown-eyed female. So go ahead and see if you can get the answers in your